So, guys, with the counters, the important thing about a counter is that we use a flip-flop set to toggle mode. Okay, so there's two ways we can use, two types of flip-flops we can use. We can use a JK type flip-flop if both the J and the K were set to high. We could also use the D type flip-flop, and this is the one I'll be using, if we connect Q bar through to the D pin. Okay, so having a flip-flop connected like this sets it to toggle mode. Okay, so what toggle mode means is that whenever my clock pin, in this case, sees a rising edge, so I'll indicate those with a little arrow here, it causes the outputs to change. So if I'll just look at Q at the moment. If the output was low and clock sees a rising clock edge, it makes the output different because I've connected Q bar to D. So if the output is low, Q is low, then Q bar must be high. Okay, but Q bar is connected to pin D, so pin D must also be high. So remembering that for a D-type flip-flop, the Q is the next D. Okay, so Q becomes what was on D, the logic level of D, after the appropriate clock edge. These are edge-triggered flip-flops. So it sees this clock edge, and Q becomes what D was, and D was high, so it goes to high. If Q goes to high, then Q bar must go to low because they're complementary, they're opposite of each other, and because Q bar is connected to D, or D is connected to Q bar, D must also go low at the same time. Okay? Nothing changes, however, until it sees another rising clock edge. And so when it does see that rising clock edge, D is low, and so Q becomes low. Q bar, being the opposite of Q, goes high, and D being connected to Q bar goes high as well. And so you can see how it toggles. So this is an important thing to notice, because every second one of these, if I do a couple more, goes like. Okay, so just looking at Q and the clock at the moment, you see that for every 2 pulses of the clock, we get 1 pulse on the Q. So the period is halved, or the frequency is, the period is doubled, or the frequency is halved. Okay, so this is an important thing about what happens with a toggle type flip-flop. Now we're going to see why we need to use toggle type flip-flops in the counter in a moment. So when we look at a counter just counts up sequentially. So let's start at 0. So this is going to be my decimal number. So we'll start at 0. We just want to count to 2. Let's count to 3 at the moment. 0, 1, 2, 3. Now I represent that as, well, how many bits of binary can I represent these numbers in? I've got 4 different numbers. So 2 to the power of what is equal to 4? Well, it's 2, isn't it? So it means I need 2 binary digits. So I'm going to call them, let's call it Q0 and Q1. Okay? And so binary, 2-digit binary number representation of 0 would be 0, 0. For the next one, 1, binary value for 1 is 0, 1. Binary value for 2 is 1, 0. And binary value for 3 is 1, 1. Okay. Now, as we go down the counting here, so we're just incrementing our count here, you notice how that every one of these, every next number, this Q0 is changing. So it's toggling every time. So if we had a clock edge that was telling us when to advance to the next number. So the rising clock edge told us to go to the next number. Then this would be a toggle mode. Now, what do you notice about Q1? It's every 2 digits. So if I were to extend this down, keep counting, I could do that. So if I just keep following this pattern of 0, 1, 0, 1, 0, 1 for the Q0, then for Q1, we've got 2 zeros followed by 2 ones, and then it'll be followed by another 2 zeros, and then another 2 ones. And so you can see the pattern continues as we go down. And so these are only changing every second one of these, or if you think about it this way, these are only changing when this goes from 1 to 0. Okay? So when it goes from 1 to 0, that's when this one changes. Okay? And so that from 1 to 0, that is a falling clock edge, if you like. So this could be considered, we could clock this Q1, so the second flip-flop, off the output, or one of the outputs of this first flip-flop. And that allows it to clock at half of that frequency. And if I were to do the same thing again, add a third one, call it Q2, then we've got, let's start at 0, then it's only going to clock when this one goes from 1 to 0. So that's going to be this one, and then the next one after this will be that one there. Okay, so we get 0, 0, 0, 0. This is where it sees a change from 1 to 0, so that's when it changes. 1 to 0 again, now it changes again. Okay? And so if I had a 3-bit binary number, I could actually count up to, in this case, that would be 4, 5, 6, 7. Now what happens when, so if I just continue on down an extra row, what happens when I get to 1, 1, 1, 1? What's going to be the next count? So once I get to that, I'm counting down. This changes to 0 because of the pattern there. This one changes to 0 because of that pattern there. This one changes to 0 because of that pattern there. So where am I back to?
You get another one, don't you?
Well, if I only had 3 bits, I just cycle all the way back round to 0. Okay? So in the same kind of way, this is like an old analog clock, but instead of having 1 to 12 on it, it's got 0 to 7 on it. When you get to 7, you keep going back round, back to 0 again. Okay? And so it's like a clock. It's called modular arithmetic. It goes round and around and around. Okay? And so once I finish here, I can go back to, if I don't have any more bits to change, I go back to my starting value. Okay? And so this is counting up. If I keep going down, it's going to be counting up. So let's actually try and draw a circuit that will do this. Okay? So I'm going to need 3 flip-flops set to toggle mode. So I need a D-type flip-flop with Q bar connected to D, or I could use a JK flip-flop if I chose. I'm going to use D-type because they're easy to draw. Okay, so I'm going to call this one Q0, and I'm going to draw another one, another 2. So call it Q1. And I haven't bothered drawing the set and reset pins on these, just because it's going to be confusing otherwise. And this is Q2. My clock. So I've got my flip-flop set up. Now I haven't connected them. What we need here is to have, we need to determine which one of these is going to be our output. So if we choose Q as being our output, so I'm going to put a little circle on there to indicate it. That's my output. Okay, so if I connected an LED onto that or some other logic, then this would be the output that I'm looking at. And so when it is logic, when this is high, it's a 1. When it is low, it's a 0. Okay, so now I've got my outputs there. I've said that the output Q is the actual output I'm looking at. And what I want is for when, for every clock edge that it sees, it causes, actually I think I've done this the wrong way around. It should be 0, it should be 2. Better. Whenever I see a clock edge on here, so this is my clock pin there. Right, so that might just be a 1 second pulse. So 1 hertz pulse or something like that, which would make this one toggle every second. Every second. Okay. It would see a rising edge every second. And then what we want for the second one is that it changes. So this here needs to see a rising edge, because this is what we call a positive going edge clock pin there, so it needs to see a rising edge. It needs to see a rising edge here when the output here goes from high to low. So if Q goes from high to low, so that's going from high to low, Q bar is the one that's going from low to high, isn't it? Because they're opposite each other. So if I were to connect that clock pin there onto the Q bar of this first one, then when output Q0 goes from high to low, 1 to 0, Q bar goes from 0 to 1, which makes this thing change, which is what we want. Okay? Likewise, when Q1 goes from 1 to 0, that's when we're interested in it changing. So 1 to 0, you can think of 1 to 0 being looking like that. Okay? That's a falling clock edge. So if that's what Q1 is doing, then Q bar of 1 will be doing that. And that's a rising clock edge. Okay? So a rising clock edge. So this rising clock edge, well this output here would be seen as a rising clock edge if it was connected to this clock pin here. And so that would make this one toggle when this Q here went from 1 to 0, which is what we wanted. So we want this one to toggle only when this one goes from 1 to 0. We want this one to toggle only when this one goes from 1 to 0. Okay? So if I were to connect my 3 flip-flops in this manner, so each flip-flop must have, and this is regardless of whether it's an up or a down counter, each flip-flop must have D connected to Q bar if it's to set it to be toggle mode. If I connect that to anything else, it will not toggle. It'll do something else. Okay? To make this count up, which is what we want it to do, we need to have Q bar connected to the clock pin. So Q bar of the previous flip-flop connected to the clock pin. And that will see a rising edge at the appropriate time and make it change. Now, what if we want to make it a down counter? So a down counter would be as if we're going not this way, but this way. Okay? So let's have a think about what happens. We want it to change. We want this one to change whenever we see. I'll just rub off the down counter transitions. So what we want is, we want to go from here this way. And you can see that when this one goes from 0 to 1, that causes this one to change. Likewise, 0 to 1 is when this one changes. This one toggles. 0 to 1, this one toggles. This one toggles here, so on. Okay? So I need to change how my flip-flop is connected, because if this one goes from 0 to 1, if that goes from 0 to a 1, well, that's a rising clock edge, isn't it? And that's what we want it to do. We want this to see that rising clock edge and change on it. Okay? So if I want to make it an up counter, all I do is I connect the clock onto Q instead. Okay? Likewise here, this one changes when it goes from 0 to 1. This one changes when it goes from 0 to 1. So we see this 0 to 1 output change here is a rising clock edge, and so I connected on that one. Okay? So if I want to make the the up counter into a down counter, all I need to do is change what the clocking pins are connected onto. So instead of being connected onto Q bar, I connect them to Q. Right, so that is probably the easiest way you can do it. There is one other way you can do it. If I were to leave them connected to Q bar each time, okay, this is a little bit more difficult. And if I were to consider, instead of Q being my output, Q bar being my output. So Q bar, if Q is 0, 0, 0, 0, 0, Q bar is going to be 1, 1, 1, 1, isn't it? When Q is 0, 0, 0, 0, 0, 0, 1, Q bar is going to be 1, 1, 0. Okay, can you see how as I go down this way on Q, then Q bar is going to have the going up this way. And so if I just consider the output of Q bar instead, so I keep them wired with Q bar connected to clock, but instead of looking at Q as being the output pin, I look at Q bar as being the output pin, so I put my LED onto Q bar instead, then I can see that that makes it a down counter now instead. Okay? And importantly, it still wraps around the same way whether it's an up counter or a down counter. With this 3-bit up counter, I count from 0 through to 7, and then I go back around to 0 again. And then I just keep counting up again. Right? It's the same if I go backwards. If I go from 7 down through to 0, well, the next one above that would be 7 again. So here's my 0, and I go back to 7. Okay? So you keep wrapping around regardless of whether you're going forwards or backwards, or up or down. Okay? Now, there is one other way, and this is not the preferred way. So there's two methods to change an up counter to a down counter, and it's changing only one of, either whether you're looking at the output on Q, or you are clocking the next clock off Q or Q bar. So if you change one of those things, it'll change it from up to a down counter. If you change both of them, well, you go from a up counter to an up counter. Okay? So you're making the change, but you're not actually, you're going from an up to a down, and then from a down back to an up again. Okay? So if you make one of those changes, you'll change it from an up to a down or a down to an up. The third way, and this isn't really preferable because what you are doing, you need to replace the whole chip, and it might not have the same pin out, so it's not particularly easy to do that. But you can change it so that it's not a positive going edge clocking chip. So a positive going edge has this symbol. So a positive going edge has this symbol on your flip-flop or on your whatever chip you've got. Okay? But you can, so this will mean it transitions when it sees that rising edge. Okay? But you can actually have a negative going edge, and the symbol for that looks the same except there's a circle in front of it or a bubble. Okay? And this is the transition, this is what it will transition on when it sees this negative going edge. So if you change this to be instead of a positive going edge flip-flop to a negative going edge flip-flop, it will change whether it's an up or a down counter. However, that's not really particularly practical because you can't just find a different one. Quite often it's got to be a completely different kind of chip. So when you're making your counters, if you choose a flip-flop that is not the 4013D type that we've been using, you need to be sure, or need to take into account whether it is a positive going edge or a negative going edge before you wire it up. Okay?